Welcome.
Thank you.
Is this your first event at the San Francisco Tech Week? Yes. Yeah, so it's our intention to make it happen the first day so we can get your attention. Yeah, so first maybe we introduce ourselves. So my name is Jun Li. This is Yi Zhang, the Professor Yi Zhang. We're both the co-host of today's event. So let me first introduce myself. I'm the co-founder and the general partner of Wisemont Capital. Wisemont Capital is a Silicon Valley early-stage investor in AI, SaaS, and automation. Through the past 10 years, I spent my time and supported a lot of companies, and many of them become unicorns. And then, for example, one actually went IPO last year is the first robotaxi company that delivered us in 7 countries worldwide. The name is WeRide. You're welcome to track that stock. And then we also successfully exited the company they sold to large enterprise in Silicon Valley, like Palo Alto Networks, Qualcomm, and so many of them are very successful. And in addition to investment, I also co-founded with a few founders and executives in the Valley. The name is called Silicon Valley AI Pioneer Club. So intention is actually to connect the leaders in the AI landscapes, because we all know AI is what we're talking about, is what today's event is about. And also recently, I co-founded a company called Elight AI. That's a new venture for myself. It's actually a data service company. It's actually bringing the human and automation services that will enable the AI applications to land faster. So our intention is to accelerate the customer and the founders here to be able to deliver to their customer faster and reliable. So if you're a founder, I'm very happy to talk to you. And so today is my honor to be one of the co-hosts here to support the San Francisco Tech Week. And our main thing is the AI frontier. So now I will let Professor Yi Zhang to introduce herself.
Thank you. So welcome to the AI Frontier Data, Agents, and Robots. I'm Yi Zhang. I'm the professor in computer science and engineering in University of California, Santa Cruz. And I'm also the director of the Generative AI Center here. Besides being a professor, I have been entrepreneur too. I founded a company called Rulai, which was on Forbes' top 50 most promising AI company in US before. I'm also an investor, researcher, and I have been consulting for corporations like Alibaba, Toyota, HP, those companies. I also have advised startup companies with multiple successful exits. So our students in our center, in our lab, has been funded by companies in Silicon Valley, from big corporations to smaller ones. Okay. I got my PhD from Carnegie Mellon University. And today, on behalf of the University of California, Santa Cruz Generative AI Center, we are excited to have you here. Okay. For your information, the GenAI Center in UCSC is a hub for research, collaboration, and education. And we bring together faculty and innovators in different disciplines. We cover a full range of AI technologies, from natural language processing, computer vision, AI agents and systems, infrastructure, security, hardware, and robotics. And we also advance AI applications in biomedicine, healthcare, climate sustainability, humanity, media, and more. So it's a pretty big center. And our mission is to drive innovation with real-world impact and build inclusive ecosystem in Silicon Valley and beyond, and also lead responsibly in AI era. We are also very proud to partner with industries, people like you, through our GenAI Center Industry Affiliation Program. And we want to connecting UCSC researchers with companies shaping the future of AI. Okay, the details actually are, if you have an agenda paper, the details are on the back of that paper. if you are interested in joining our industry affiliation program, we have our corporate engagement team, John,
Yeah.
John and Molly. They are here. Feel free to talk with them. They are very nice person. Or talk with UCSC professors. We have multiple professors doing different kinds of AI-related research here. Talk with them. You can talk technical details with them. So today you are going to hear leading voices exploring the AI frontier. Hopefully, let's make it an inspiring time for sharing, connection, and discovery. Our next session will be the robotics panel.
Yeah, we're going to start the panel first. But let me first actually thank Yi and the UCSC to sponsor this beautiful event venue, right? And also part of the food too. Yeah, let's give them a round of applause.
That's the staffs and the people in UCSC and also AI Pioneering Club and the volunteers.
Yes, and I think the intention of this conference is actually to bring the research and the industry leader and the startup founder together, so we actually can have a really deep dive talk. Yeah, because they have done some really frontier research, and then it is the founder and also the executive to make it happen in the industry. So next, let's welcome our first panel, robotics. I'll give my mic to the moderator.
Yeah, so please.
Yeah, just go. So let me introduce the moderator, Professor Tae-Min Hu. He's an assistant professor at UCSC, and he's the head of tactile manipulation lab in UCSC. Before joining UCSC, he was a postdoc in UC Berkeley. His research focused on robotic tactile sensors, perception of grasping, dexterous manipulation, and machine learning for application in industry tasks, and human assistance, manipulation, locomotion in all kinds of challenging environment. Dr. Tae-Min Hu received his PhD from Stanford University.
All right, yeah.
So yeah, thank you for the introduction, and yeah, so let's start this robotics or embodied AI panel discussion with our outstanding panelists. So let me introduce one at a time. So Leo Ma. So we have Leo Ma, founder and CEO of RoboForce, which builds physical AI-powered robotic labor systems. RoboForce was recently recognized as a 2025 technology pioneer by the World Economic Forum, joining the ranks of companies like Google, Airbnb, and Dropbox. Before RoboForce, Leo co-founded Syngin, right? Syngin, leading it all the way to a NASDAQ listing, and previously worked at Baidu USA on autonomous driving system. He holds a master's degree in computer science from Carnegie Mellon University and completed executive education at the Wharton School. Okay, and next we have Tao Chen, co-founder and CEO of DexMate, a company advancing AI-driven dexterous robotics. Tao completed his PhD at MIT CSAIL, and he received multiple recognitions, including the Best Paper Award at Coral, one of the most prestigious robot learning conferences, and has published in Science Robotics as well. With prior experience at Toyota Research Institute and NVIDIA, Tao brings a deep blend of AI algorithms and real-world robotics hardware expertise. Okay, and lastly, we have Steve McGuire, and Steve is an assistant professor in electrical and computer engineering department at UC Santa Cruz, where he leads the Human-Aware Robotics Exploration Lab, in short, HARE lab. And his research focuses on human-robot interaction and autonomy in field robotics, exploring how robots can safely and intelligently collaborate with people in dynamic outdoor environments, particularly in agricultural settings. Okay, Steve holds PhD in aerospace engineering from the University of Columbia, Boulder. Okay, so that was an introduction of our panelists, and I want to open the discussion with this question. Like, please introduce your current projects and your broader or ultimate goal of your group and your company. Okay, who wants to start? Okay.
This is a great example, by the way. We have automation without human interaction as a consideration. There we go. Okay, wonderful. Thank you for the introduction, Tay, and thank you for having me here. The current projects that I have going on in my lab revolve around using robotic technologies to improve the way that we do agriculture and ecology, particularly on the research side, where we can use robotics to improve the science that's done. The current state of the art of some of my peers involves an army of undergrads and a hand measuring tape. We can do better than that. So one of my current projects involves analyzing the deployment of wireless sensor networks so that we can figure out how to best instrument farm fields and deploy precision agriculture in ways that are economically sustainable. Thinking about really the full life cycle. It's not just throwing a sensor out there, it's how much does the sensor cost to build? Where do I put it? How do I harvest the data from it? And how do I collect it when its useful life is up? And really thinking about that full life cycle. That is really the focus of my lab, and sort of the background that I come from in field robotics includes the DARPA Grand Challenge in '04. I was part of Team ENSCO. The DARPA Subterranean Challenge back in a couple years ago now. We took home 3rd place. And a career as a Marine Corps helicopter pilot. So that's what I bring to the table and my view on the research.
See, and Tal?
Yeah, hi everyone. So I'm Tal, I'm the CEO of DexMate. So maybe another question is, I think we are here to discuss the challenges in embodied AI. It's a very hard problem. I think it's a very comprehensive subject. Involves like mechatronics, mechanics, planning, control, AI, software, navigation, whatever, a lot of stuff coming together, and then we can build a robot to do something. It's a very challenging subject, and I think it's very hard for many people. So our goal here is to empower everyone to be able to build a robotics application. We want to make it really, really simple. I believe there's a lot of things that we can reuse. Not everyone needs to build it from scratch, so that's what we have been working on, and I think in a few years, many people can easily build a robotics application, whether it's like deploy the robot to clean up the table, or whether it's to deploy the robots in a hotel. We can build. We are building the technology that can enable everyone to do that.
Hello everyone, Leo Ma here. I'm the founder and CEO of RoboForce. I see a lot of friends here. First of all, happy Moon Festival. So this is the moment we realized this Moon Festival. Last night we were at the RoboForce RoboLand. Our robot is testing in the field, and we look at the sky. What is a very round moon? So we realized, oh, it's the Moon Festival already. RoboForce is building. We're aiming at building the world's most advanced robo labor to take on the things that shouldn't have to be human to do. Think about it, that is all the work that is dirty, dull, and dangerous. And before it was a dream, now we believe this is the best time to do it. A lot of friends getting to know RoboForce from the incredible team that we have. If you're familiar with our domain, Carnegie Mellon Robotics, Amazon Robotics, Tesla Robotics, ABB Robotics, Michigan Robotics, and there's a longer list from Google, Waymo, Apple, all the tech leaders that decide to, 2 years ago, decide to quit the job and join a small startup that's called RoboForce. So we are making good progress. I'm very happy to share information potentially useful for all of us. Very happy to be here.
Okay, thanks for the introduction of your company and group. And let's move on to some bottlenecks or challenges. So what's the biggest bottleneck or challenge, well, in achieving your ultimate goals? So yeah, it could be a technical or anything. Yeah.
So at least in my work, I can tell you hands down, the biggest bottleneck is data. Specifically labeled data that is completely representative of the scene. And for the kinds of challenges that we're interested in, for example, we see a fungus on a tree. We'd like to know how big that fungus is. We'd like to know the species of the fungus. We'd like to know the species of the tree that the fungus is on. We can capture lots of representative images, but being able to ensure that we have a full cover of the variation in the natural world is really hard and really expensive. There's also elements from my work, particularly regarding plant disease, where there's ethical considerations. We can't ethically infect a plot with a fungus and destroy a crop to get data. That's not okay. But yet we're still interested in, we're stuck between relying on nature to provide us with our training data when these things happen organically. And that is a major bottleneck in the progress that we can make, particularly with AI techniques in image recognition and classification.
Mm-hmm. Yeah, I think when it comes to challenge, there are at least a few ways to think about this. The one is, I think the first one is the business, because the startup is, by the end of the day, it's judged by its own revenue, by its own business model. So I think for the physical AI, there's a big gap between like what the robots can do, and then what people hope the robots can do. And then also when we try to convince customers to buy our robots, we need to navigate through the very complicated, like the hierarchy in the company, to convince them to like massively deploy our robots. So those are on the business side. But I think on the other side, on the technology side, I think there are, depends on what we do. So for us, I think we have challenges on both like the hardware and then also the model training, because we are building a full stack robotics solution. But I think for us, I think we are pretty confident in the technology side. I think we know exactly what to do. And over the past year, we have been able to overcome a lot of the challenges. So I think moving forward, I think by the end of the day, the challenge comes from the business side.
So the question is about the bottleneck and challenge.
Yeah.
So we see bottleneck is actually quite different from challenge. And the definition of bottleneck is potentially out of our scope, like beyond what we're working on, but we're constrained by, right? So that's typically a bottleneck. And challenges could be the initiative we're working on. As I just described that we started 2 years ago, now the bottleneck we see at the RoboForce, given the AI model data and the system is working both indoor and in the RoboLand, we see the bottleneck is actually the supply chain.
Mm-hmm.
So if you take HD for their component, if original from Japan, and they're at the 500,000 size in terms of the total volume of the year, and based on what we need, that is a very different scale and a very different number. Happy to share, as of today, there are more than 12 countries, more than 35 early customer partners are lining up with a robot order for more than 11,000 units of the RoboForce system. That is 11,000 units, very different from 11 units. So that is beyond our scope, and we are constrained by. So we we are very happy to working with the best supplier across the supply chain. So hardware-wise, there are 15 subsystems, 660 smaller components in our system. So the better, the more valuable the supply chain is, we believe the penetration rate of the market will be much faster. So that's a bottleneck. In terms of, I'll keep it short in terms of the challenge. We see a pretty clear picture towards the next step. To summarize, there are model, the current model structure, and a lot of model structure from the previous wave of language and then language intensive. The structure could have much better performance and reliability and generalization for the application we're working on. And data we mentioned already is not captured at all, a lot of the cases. So last night I was interviewing a junior back in CMU. So the example is if you ask a simpler demo of a robot to pick up the apple, put on top of a plate. The model recognize what is the apple, recognize what's the plate, and recognize what's put, right? So it's quite straightforward. However, if you're really building a robo labor that is working for the customer say, okay, RoboForce system, pick up the M6 bolts and nuts, put on the 311 per lane, and tighten it up to 10 Newton meter. The model never heard of what is the M6 bolt, what is a 311 per lane, and what do you mean by secure it? So that is the opportunity we see is a gold mine. And so the data and the model is 1 and 2, and hardware. So that is linking to the supply chain. So that's the constraint and the challenge we see.
Yeah, thank you so much. And yeah, maybe, well, it might be, I mean, the following question might be related to it, but so how, so far, let's say, well, since it's an AI event, so how has AI specifically accelerated your work so far? So someone can start.
Well, I mean, I work in an academic environment, so particularly part of my job is to train students. And from that perspective, the use of large language model-based techniques as trainers and the ultimate reference librarian is invaluable. That being said, there's also the classic abuse, misuse, and disuse from the 80s of where my students get over-reliant on these tools and don't recognize that there's a lesson to be learned about how to use those tools appropriately with an appropriate level of and I saw this in the questions we're going to get to later, and it's a very loaded word. I'll use it anyway. Trust. So how has AI sped things up? As being the ultimate reference librarian for code development, for sure. As far as developing ideas, that's one of the big sort of reasons for my work is to reduce the need for human, to change the way that human workload works. We're not eliminating the human, we're changing their role so that particularly in agriculture and disease identification, I'm using those subject matter experts in a way that befits their expertise rather than having them do grunt work. And in that regards, it's a huge promise. The challenge has been understanding when it doesn't work and quantifying that and knowing when you can and can't trust the system.
Yeah, I think that so maybe a few ways to think about this. First of all, we use AI a lot in our daily work. So for example, we use cloud or we use ChatGPT, all this stuff to help us improve our like work efficiency. If we want to code something, we probably don't really need to write a single line ourselves. I mean, most of the time we just give very good prompt. But still, humans are doing the designing. Like we are telling the system what to do. So that's the very important part. I think even though everyone can use cloud code, not everyone, the output are not the same from different people. I think the design logic is also still very important even in the large language model area. The second thing I think is also we got inspired on how AI works. And I think in the physical AI, it's the same thing. By say same thing, I mean, like in the past, like people build a modular system, not modular, I mean, build a classical pipeline. For example, we build a navigation pipeline, we build like object detection, we build object post-estimation in order to grasp this object, things like that. But now I think the modern trend is to try to get a lot of data, and then we train one end-to-end model to do this. It can still be modular. I think that these two things are not conflicting with each other. But then how do we train this large model? So I think in the large language model domain, we do, for example, large scale data pre-training. In the robotics, we can do something similar. I think we can collect a lot of the data either from teleoperation or from like simulation data or from human data. We do a lot of the large scale pre-training. And then, but even in ChatGPT, people still do reinforcement learning, post-training, try to guide the model to do what we really want the model to do. Same thing applies in the robotics. We still need to do a lot of post-training for a specific task for specific hardware. So I think the general guideline, I think, still follows in the physical AI domain.
Well, I see two major impact or major change from a very different direction. One is the technical side, of course. Without the recent breakthrough in across the board regarding AI, we will not build a RoboForce at all. So most of things are either built the model itself or enabled by that. So I think that's quite clear. One thing to mention here is the way we think about building the system. Excuse me. The way we think about building the system is actually quite different. Internally, we are driving forward the whole RoboForce system of the whole effort from company is one AI native or AI-oriented system. What do I mean by that is if we're familiar with the design of a TikTok, right? So when we swipe, that's actually annotating and providing data. So we think about throughout the whole life cycle of how things getting done in the company, how do we get the data, how to get measured and evaluated, how do we really get it going? So that's a major change. Comparing to before, we have only the perception part, we're focusing on the AI, and the traditional part is not involved. But now the whole company is being designed around it. Second is about if I summarize as organizational excellence, starting with recruiting. We realize Gen Z new talent that much younger and then have a quite different view of how the system will work. One example, also from a recent interview, if you do a matrix manipulation, matrix A multiply matrix B, is a very classic, is well solved, well optimized from the architecture of a computer system. However, if you realize that the most recent update from anything regarding rendering, once you have completely enough metrics manipulation, as a big chain of that, training a model to do that is actually higher performance and much low cost. So that's what we see that really change the people that we are inviting into the company. The first thing they think about is, okay, let's train a model to do it. So it's different from when I initially got started. Yeah.
Yeah, that's great. And well, the next question might be somewhat related, so maybe you already covered it some, but what do you expect or what will be the most critical AI breakthrough that you are anticipating or you want for robotics in your work?
Oh, what I would absolutely love to see is work in generalizability and explainability. I think those are the two elements that we're currently missing, because right now we can establish a trust region where we're pretty confident that something will do the right thing when it's within its training data set. But when you step outside that, when you try to extrapolate, there's no, the assurances just aren't there. And at the end of the day, whether you give an AI technique command authority depends on the explainability, that it's going to have to justify and rationalize any action to a human. That's sort of the world in which we live right now. And I think those are probably the next those are what I see as as major hurdles to enabling a AI system to actually have command authority as opposed to just advisory authority over some sort of process or task.
Yeah, I think I definitely agree with that. I think the biggest breakthrough in robotics that will probably come very soon is the foundation model. Particularly, I care more about like a cross task. There are companies out there who also care about, like, for example, cross morphology, cross hardware. To me, I don't really care about that too much. I mean, it's not I don't care, but I think a cross task is a much more important problem. And if we can solve the generalization problem across tasks, we can solve the problem that will make the model work for different hardwares, same as self-driving car, like self-driving algorithms. I think there's traditionally, a few years ago, most of the robotics companies, when they try to deploy the robotic solutions into factory, into like warehouse, it turns out that there are a lot of customization needed. So if I onboard a big customer, say for example, some big name customers, they will have their own requirements, and then I have, as a robotics company, they typically need to invest a lot of R&D resource in order to customize the solution so that it works for that customer. And this is not very scalable. It actually makes the revenue model looks really bad, because in very few cases they will actually make money. Well, I think with the foundation model, things are going to change, because we don't really need to train everything from scratch for any new customer. We can reuse pretty much all the data, pretty much all the model we have, and then do a quick tuning, do a quick post-training for this customer on this new task. It doesn't need to be 0 shot. It can be like 1 shot or a few shots. That's fine. But I think the R&D cost will go down significantly. From the customer side, they will not notice too much difference, but I think the underlying technology is changing. It makes a big difference for robotics companies. Yeah.
Well, at RoboForce, we see the more we work on this in RoboLabor for the hard condition, shouldn't have to be human. The more conversation we have with the customer, we actually realize something different from what we initially thought. So we want performance and generalization. But the question is generalization a necessity, sufficiency, or is a superiority? Meaning, which one of the customer asking us, okay, Leo from RoboForce, we generalize to this certain level as we have been, has been in the popular public perception of a generalization of a model. So far, none of the customer really asking that. Second, once you have generalization, is that work being done or green light or check? So it's not sufficient, or it's not really comes with as a necessity. And we realize actually we're looking forward to getting to the question. We're looking for the performance of a RoboLabor system to get the work done with a sweet spot of a generalization. Meaning, take a energy project as example. We're engaged with any 1 gigawatt ultra scale solar site. There's about 30,000 acre land, require 3,000 worker year. 3,000 worker year. Worker year is a unit. If you have 1 worker, it will take 3,000 years to build it, right? So to do that, we realize it may not be that high level of generalization, but performance really matter. Right? If you look at the most recent open model, we're talking about 80% or 85% success rate. So if we divide it by count by MCTF, the mean count to failure, is about 5 times a failure, 5 times or 10 times a failure. Customer will not take a system that every 5 times work on something, there's one failure. It doesn't work, right, in a simple way. So in short, the more we work on this, the more we realize having a high performance system with efficiency and a sweet spot of a transition is any company deliver that would be a tremendous value. Yeah.
Okay. Yep. Yep.
Thank you so much. It's mostly about the generalization. Do you want to add something? Okay, yeah. Okay, sounds good. And next in my list is about the humanoid robot, actually. So nowadays, many recent robotic hype, I think it's coming from humanoid, the full human-like robot. And as far as I know, RoboForce and DexMate also having some upper body humanoids, but the lower body is the wheeled robot. So my question would be, is the humanoid robot is the right solution for the future robots, or is it not necessarily be the case? So, yeah.
It depends.
Yeah. Sure.
And I mean, all joking aside, the human, it depends on what the expectation is of the system. The human form is not exactly fit, it would be having a human inspect a pipe or having a human carry heavy objects. Anyone who's experienced lower back pain can tell you exactly how well that works. The human physiology or morphology is not exactly ideal for a lot of tasks. Now, I think that there's room for especially for co-use of technology, where if you have a system designed for a humaniform, then sure, we can actuate those controls. I mean, we saw the DARPA Robotics Challenge with Atlas, turning valves, opening doors, that sort of thing. But I think primarily it will be it depends. And I think to say all humanoids all the time is really going to limit us, especially for those of you who may be traveling in robots for upcoming holidays or otherwise. It's one option among many.
Yeah, I think for humanoid, I think the first question is how do we define what is a humanoid robot? Do we define it based on does it look like human, or does it have some similar function as human, but it doesn't need to look like human? So I think there are, generally I view humanoid as a very broad term. I think the most important thing is the functionality, not necessarily the appearance. It doesn't necessarily need to look like human. It can even be superhuman. It can have, for example, 4 arms, 4 robot arms, 6 robot arms. As long as it can make it can be as dexterous, or it can do the task dexterously. And I think in terms of the form factor, I don't feel like there will be only a single form factor that will exist in the future. Say just one humanoid robot form factor that can work in all the industries. There are reasons why we invented, for example, wheels. We invented wheels because human can never run faster than wheels. Same for airplane. We don't invent the airplane based on how bird flies. So there are different things going on, and I think different design will exist. But on the other side, I think there's also a thing that we need to consider is the scaling fact of the hardware. So if we can, in theory, we can design, for example, 1 million different hardwares. And if we sell each hardware for 100 units, then each unit is going to be very expensive. But if we design, for example, 20 or 30 different hardware form factor, maybe for each one we can sell and deploy millions of them, then each hardware is actually going to be cheaper. So I think there's a trade-off between we don't need to design a lot of different form factors. I think there will be some convergence, but it will not be a single one. And then I think it depends on the application. different application will, a different form factor will work better in different applications. But on the other hand, also the software and the AI model really matters. So we don't want to invent a different AI model for every different hardware. We don't want to reinvent the software architecture. We don't want to reinvent the software infra for every different hardware. I think all those software layer stuff should be the same. But the hardware-wise, I think there can be variations, but not too many variations.
Well, actually, I totally agree. There will be multi-form factor, and the need of multi-form factor should be driven by the actual customer and product need. If we need to run faster, the convergence of not too many, not 2,000 of them, converging with 3, 4 type of the form factor of a robot. We also see that that's primarily driven by the supply chain. It's just much efficient in terms of cost and value to consolidate into several types. I want to answer the question in the opposite way. Why a certain humanoid with 2 legs is important? I think there's a strong technical reason behind that. I realize surprisingly that's not be recognized so far. Number one, if the system require high dynamic, that a company is building a NBA trainer, NBA player robot that play according to the NBA role and slam dunk with that require the level of jump from the kinematic and the dynamic model from the system. That anything needed a high dynamic that require or is one of the good choice to have a human form. So that's one. Second is anything that is data rich with 2 leg. The reason we have multi-form factor is none of the customer indicate most of the work are being done by the lower body, not the upper body, right? So where is rich data with data that's of value, there will be good model that easily happening there. So if that's the case, that's second. And the third reason is technically, if the form factor is closer to our application of a daily life, that it looks more like a human. In the recent conference, I saw many even soft surface robot is cute and is easy to accept in daily life. Yeah, that is a value to look like a human or is a smaller size. Beyond that, if it is not technically require high dynamic from the kinematic and dynamic model, if it's not providing the value, it just look small and cute, and is not data rich for a better model, we don't see a strong reason why it have to be like human form. So we go with a multi-form factor.
Yeah. Great. Yeah. Thank you so much. Yeah. Yeah.
One of the things that often gets overlooked is the human factor, the human side of things, in that when we design systems, the users are not the people in this room. The users are the people on the other side of the glass, who are not necessarily subject matter experts, and for whom a human-like form, and potentially getting into the uncanny valley, but then those sorts of issues where there's a lot of opportunity for robots in, say, a home healthcare space or an elder care space, where the humaniform becomes it's not just about the function, but the form matters a lot in order to accomplish the given mission.
Yeah, actually, that actually is a great point that connects to the next question. So the next question will be about the safety in our daily life or our human environment. So we all want to bring our robots close to us, and we are developing some home robots or workforce robots. Should be still need some human working together or coexist. So is there any AI techniques or some other techniques that helps the robot to be safe around us? So yeah.
So if I can draw, there was a CVPR paper years ago written by none other than John Lasseter about the role of intent communication in animation, of how animation appears more lifelike when you telegraph your move before you take it. Those kinds of techniques where we don't, is it strictly necessary to accomplish move the widget from here to there, tighten the bolt? No. The only reason you would engage in that extraneous motion is to communicate to a nearby human, hey, this is what I'm doing. I'm about to move, therefore you need this cue. And so one way that we could improve safety is by including some of those motion cues in encoding those into the way a robot moves is a path planner. That's not just move all your joints via the IK rules and respecting physics from here to there, but to also do so in a way that's predictable and communicable to the humans. Those kinds of considerations, how to encode the soft squishy part into, how do you get training data for that? How do you quantify those rules? This gets into a lot more of the human understanding the human condition rather than just foundational physics.
Yeah, I think that the current AI, I think we see a great progress in the way we train the AI model. I think if we collect the data in a safe manner, in the test time, actually, most cases is pretty safe. The trajectory is like constrained in the similar manifold. But of course, like for AI model, one thing about it'll make a mistake. And for robot, if it makes the mistake, it's a pretty bad thing. So I think the way we solve this is by co-optimize the hardware and also the software, also including some classic control theory. So for example, for the hardware level, we typically put on some like force sensor on the robot, so it can actually sense how much force is getting from the environment. If it's some super big force, then the robot should respond accordingly. And then on the software side, we also do a lot of, I think in the embedded system, in the low-level controller, we do a lot of tracking, whether there's a collision, whether there's is something unexpected happen. So if I say I send a command, the robot is expected to go somewhere, but then it didn't go there, then something is wrong. Something is happening. So I think there are, to make the robot really safe, we need to build in several layers of safety tracking, all the way from hardware and then the software embedded system, and then from the AI model, when we collect the data, we need to collect a lot of this kind of safe data.
Well, I have a very short one. One of the reasons we build RoboLabor is to not to have human to get in the environment to take the risk. So our conversation with our customer is very simple. They simply don't want to have human to think about middle of nowhere building a big solar farm and ultra scale data center. That a lot of new projects regarding data center is there under the side of the mining side. So not to have to have human to do it, but as a human economic system, we need it. That is actually one core value we provide. A simple way is to, ideally, we get these things done and not require human to do it. That's the beyond availability cost. So safety is a core value.
Thank you so much. And well, I have a couple more questions, but I want to open the question to the floor. If you have any questions to our panelists. Yep.
Yeah. My name is Zheng Xia. I'm a CEO. Sir? Yeah. Okay. Yeah, my name is Zheng Xia. I'm a CEO of the AM Sim LLC. So we will do the simulation. So about the last questions, we are talking about, okay, the safety, right? The safety, okay, I think sometimes it's hard and not easy to get real data from real world to train your model, like in the corner cases, right? So in that case, maybe we want to use the simulation, build the virtual environment, so we can design different corner case to train our robots, right? Okay. So guided by the AI. So I have a question for for you guys. Okay. So I think the AI, so what the AI can do, for us, I think two things that we need to think about. Okay, how AI can help us to, reduce the cost, right? The second thing is, okay, how the AI can help us to improve the efficiency, right? So now we are using the AI agents to very quickly to reduce the cost and also to improve the development efficiency. So I want to ask a question. So how the AI agents to help you guys to to improve your RD procedure? Okay, thank you.
I can just go. So one of the roles in my agricultural work is our big picture goal is to get to the idea of a digital twin for a farm where we're monitoring dirt, we're synthesizing and simulating dirt to plant and then comparing it to reality. A lot of the AI components there, treating AI as an arbitrary function estimator, where we don't have great models for the underlying physics, or we don't have a great understanding of the underlying physics. I think my take on this is knowing when to deploy AI. If we have a decent model of the underlying physics, then training some sort of deep learning network isn't really appropriate because we throw away a lot of understanding under the hood. And so that's something that at least I run into fairly often, and trying to convince my students that actually we do know how water flows through dirt and this, that, and the other thing. And we don't need to just throw a model at it and hope for the best.
Well, I'm not exactly sure I understand the question precisely. The approach we're taking is quite simple. End of the day is cost and value. Right? As a faster, rapidly growing startup, anything that justify a significant saving of the cost produced the value that we either was very expensive or that fit our need is something we'll take. Right? Since you mentioned you're building a simulation company, any of the ones that open to be useful for us, we're evaluating and answering cost and value, we'll go do it. If it's a fancy but not really useful, very expensive, we'll just green light for the ones that easier and higher value. So we do see AI and agent and more as a tool for us to really quickly build a company.
Tao, if you want to add, we have a few more seconds.
Yeah, I guess for I think that's essentially what we want to build. We want to build like all these kind of agents so that people can find super easy to build a robotics application. But I think the current status is not there yet. I think still there are a lot of the place where human knowledge is very important. That's actually I think why I think now building a robotics startup probably sometimes still require PhD. But I think in the future that will change as the agent system becomes more mature. But I think right now when we, for example, think about the simulation data, think about the real world data, we need to understand like the advantage or pros and cons for each kind of data, and including the human data. And the way we do this is like based on every task, we analyze it and then see what kind of data is best. Whether it's simulation is good for the rigid bodies task. And then for real-world data collection, is good for example, deformable objects. Also, we need to consider the cost. So there are a lot of things that we need to consider. I think still right now, it depends on the human knowledge. But hopefully in a few years, I think we can make the AI system to do this.
And just you mentioned simulating a human. That's a great example of a system that we don't have a great first principles model for yet.
So that ends our panel discussion for the first section. So thank you so much for our panelists, and I'll hand it over to Professor Yi.